in the germ cells, or when like cells become a sperm or an egg, they actually, certain regions get silenced depending on whether you're a male or a female. And this leads to a lot of really strange inheritance for different diseases. And like, if you were to draw a pedigree, like the way that it's inherited wouldn't really make sense. And the only way that you can make sense of it is like a very classic, or the classic example that we talked about was how imprinting is spina bifida and
male
females.
Boom!
Yeah. Well,
Boom!
So,
Stop being a baby.
what you really have to understand is that so like, say we have these two chromosomes, and in the male, this region gets silenced, and in the female, this region gets silenced. So when you make a new organism, and it gets one of these and one of these, they're going to end up having this and this. And this is going to be silenced, and this will be silenced.
Yes.
Is that how you get like diseases?
So that's how like.
Is that like the whole thing with like Angelman's disease or whatever?
Yeah. So like.
I thought Angelman syndrome wasn't that like heterozygous mothers?
Oh, that makes
That's
sense.
because of the.
Because you're losing part of the mother.
Yeah.
Do you mind paying attention for this one, Rich? Because I really don't understand imprinting.
Well, it kind of makes
Hold on.
sense.
Let me restart. So.
Yeah, Angelman syndrome. You're right. Heterozygous children are heterozygous.
Bitch, you know we right. I just wanted to show up on the video. Imprinted, motherfucker! I love you.
So let's say in the male, this orange chromosome gets silenced here, and this pink one gets silenced here. And in the female, the orange gets silenced here, and the pink gets silenced here. So when it makes gametes, one, or it's going to be and then when those fuse, you'll have one. And one will be from the mother, right? One will be from the father, or.
And they're not usually on the same genes, right?
What do you mean?
Maternal and paternal gene imprinting for imprinting. It's usually not the same gene.
Yeah.
If it is, you have complete.
Well, so you mean like this?
Yeah, they're never like on the same gene.
Well,
right?
it could be in the same gene, but it could be like in a different region.
Yeah. Okay.
Or, so you're right, yeah. The gene, but different area on the chromosome. Yeah. You're absolutely right. So, what happens is, it could lead to a disease because if the one that you inherit from, say this is functional, or no, say this is non-functional, and this here is functional, and when you inherit this from your mom, the only one that can be expressed is the non-functional one, because the functional one is getting silenced.
Oh, what were we talking about?
Huh?
What?
Okay,
Repeat
so
exactly what you just said.
So The thing about silencing is that you have two chromosomes, right? One from the dad, one from the mom, and they get silenced differently.
In different places.
In different places. And so, say, for an example, say that in this chromosome, this gene leads to deafness, right? And in the father, he is homozygous for the deafness gene.
So he's
And the mother is, yeah, so no, so he's, he's homozygous for the deafness gene. He'll become deaf.
He's deaf.
He will be deaf. She's homozygous recessive for the deafness gene. She will not become deaf. But then if you get these two gametes together, this one is silenced, the non-deafness one. So when that embryo develops, it's gonna be deaf because the only
It's gonna be heterozygous, but it'll still be deaf.
it'll be
Because the dad
exactly
is still homozygous.
yeah
So
because
it will act as a homozygous negative.
yeah cool. It will be homozygous and it will develop deaf because the only gene or the only chromosome that could be expressed
Is the-
was the only functional one or the non-functional one, and that was the only one that was able to express.
Going up. That makes a lot of sense.
But
Can
but
we,
consider
now would that
that's
also
someone-
work if we said that, like, okay, say, take it and do it reverse. Say deafness, you have to have both of them silenced.
Both of them silenced in
Yeah.
order to be deaf. Well, that's something else, and that's like well, wait, no, what do you mean?
Say if you took it reverse and said, okay, the mom is deaf because at that locus it's silenced,
The mom's
and the
deaf.
dad is not deaf, then he would, the person with the heterozygous would still not be deaf, and the only way he could be deaf is if his dad has
Yeah, like if this
silencing
was
there as well.
yeah.
Okay, so it's just the same as any other gene.
Yeah, but like it creates more variability
Yeah.
because like you may or may not inherit that gene based off of this silencing.
So really what you were saying is it all fucking depends.
Yeah, exactly.
Which would mean is no.
So you're gonna